video about variable length subnet masking, something that sends a lot of people crazy. Now in class you will have used the graph paper, gone to binary and done everything longhand, and that's a very good thing to do to get a real sort of sense and feeling for what's happening underneath the covers. The good news is that once you're comfortable with the concept of what's actually happening, there are some shortcuts that you can use that mean you don't have to go to binary in all cases to find out what's going on, to troubleshoot stuff, and to figure out how you're going to address things with different subnet mask lengths. So this video is going to show you some of those. Okay, first point, it does all rely on binary. There's no way out of it. If you try to shortcut things and go straight to this method without exploring the graph paper, the ones and the zeros, it will not make as much sense to you and it will not be as useful. However, once you are comfortable with the concepts, you don't have to go to binary to figure everything out. Once you have done a few examples with binary, you'll start to notice some things. There are some sequences, and those sequences have a meaning behind them. The first and most obvious statement is that the mask, as we write it out on the graph paper, is a sequence of 1 values stretching from the left towards the right. After the final 1, you just have a bunch of zeros. As this is going across a 32-bit value, every time you add a 1, you are incrementing by a factor of 2, because that's what binary is. Each column, if you like, of the value represents an increase to the power of 2. So this means that the decimal representation of that mask also increases in powers of 2 as you add or decrease to its length. How is that useful? Well, here's some examples. We know that all 1s in an octet, if you add up all the values of the decimal representation, it comes to 255. If you take away just the last single solitary 1, replace it with a 0, add up all the values, that's 254. With 2 zeros you get 252, and with 3 zeros you get 248. You should notice that the decimal value on the right hand column decreases along with the power of 2 that we have. 2 to the power 0 is 1. That's the decrement from row 1 to row 2. 2 to the power 1 is a decimal value of 2. That's decrement from 254 to 252. 2 to the power 2 is 4, which is the decrement from 252 to 248. And so on. That same concept carries on down the line to 240, 224, 192, 198, and finally 0. So how does noticing that help me? Well, the first thing to notice is that from 0 to 255, that's a total of 256 numbers. 0 is a number in this instance, and it's our first number. Subtract the mask value from 256, and that tells you how many addresses exist within the subnet you've created with that subnet mask. So for example, if you have a subnet mask that ends in 240, so it's 255.255.255.240, you subtract 240 from 256, and that leaves you 16 addresses. If you had a 224 mask, that's 32 addresses, etc. As well as telling you the number of hosts, that obviously tells you where a new network starts. With the 240 mask, there are 16 subnet numbers, so clearly network starts every 16 numbers with that subnet mask. That tells you that the new network starts at 0, the next network starts at 16, the next one at 32, the next one at 48, and so forth. So if you happen to be troubleshooting, and for example you have 2 routers connected by a single serial interface, one is addressed as 10.1.1.15 with a 240 mask, the other is 10.1.1.17 with a 240 mask, you know that they are on different network numbers and will not be able to ping each other. So that's an easy way to troubleshoot something where somebody may have misconfigured an address, and based on the mask they won't be able to communicate with each other. So that was just looking at the variations of mask values in the fourth octet. Sometimes you'll see the third octet also being used in the subnet mask. Basically the same principles apply. So if we have a 10.1.1.1/22 address, that tells me I have a 255.255.252.0 mask. So my mask value is changing from ones to zeros in the third octet. All the same logic applies from the previous example of changing the fourth octet value. This tells me I have a new network every 4 numbers in the third octet. In this case, because I've addressed the interface in 10.1.1 space, it tells me that the network starts at 10.1.0 and goes all the way to 10.1.3.255, and that's what you'd have as a network available for you to address in the same space. The next network starts at 10.1.4 and goes up to 10.1.7.255, and then it'll be 10.1.8 up to 10.1.11.255, etc. Let's look at how this could help us on a router. So here, so now we have a simple setup in Packet Tracer to explore some of this network masking stuff. So what I've got is a left router and a right router. What I'm going to do is configure a network mask that we're familiar with initially. So let's put an IP address on the left router, gigabit 00 of 10.1.1.1, and give it the 255.255.255.0 mask. That's what we'll generally see in practice. Most people are giving you 24/24. So anyway, here put a configuration on the right router, G0, IP address 10.1.1.2.255.255.0, and let's do a ping. Okay, so that's good. Let's have a look at what this appears as in the routing table. This is pretty much as we would expect. We see that there is a connected route with a /24 mask connected to gigabit 00. It's cool. Okay, this local route here, this is a /32. It relates to Cisco Express forwarding and is out of the scope of our discussion at the moment. So you don't need to pay attention to those /32s, the local routes. We're just going to be looking at the connected route, the /24. So that's pretty straightforward. Let's do something a little more interesting for our purposes here regarding variable length subnet masking. So if I change the address here to 10.1.1.14 and give it a 255.255.255.240 mask and spell address correctly, that would help. And go on here, say IP address 10.1.1.17 255.255.255.240. Now let's see what happens when I try to ping between these two addresses now. Do ping 10.1.1.14. Yeah, we don't get anything with this. So Let's look at why that is the case. I see here that I have a mask ending in 240. If I subtract 240 from 256, that tells me I have a new network starting every 16 numbers. So I will have network starting at 0, at 16, at 32, at 48, etc. How do I prove that out on the router? Okay, so I'll do a show IP route, and now the router is telling me that instead of a /24 address, I've got a /28 address, and critically that .0 is telling me I'm in the first subnet possible with that mask. Let's see what I've got on the right hand router. Aha, we see here equally I have a /28 network, but because of the address that I placed on the interface, it is now in the .16 network, so the second subnet. So from the perspective of these two routers, because I have now placed a subnet mask of /28 and addressed the two interfaces from different blocks or different subnets, they can no longer communicate. There would be a couple of ways to fix that. You could move one of them into the subnet range of the other. So let's do that on the right hand router. IP address 10.1.1.10 255.255.255.240. And let's ping back to, I have problems with my fingers today. Let's go ping back, and we have success. Let me show you another way. We could change the subnet mask. So if I change the address back 10.1.1.17 space 255.255.255 and select a mask, have 32 addresses. Take 32 away from 256. I have a 224 mask. And now let's try and do a ping back to this guy. Doesn't like it, so let's go back and change the addressing on this side. Okay, this is still not working, so we have some troubleshooting to do. Alright, let's do a show IP route first of all. This is telling me 10.1.1.0/27 is directly connected. We have mismatching subnet addresses. I put in the wrong net mask on the left router, and that's telling me that I've still got the 10.1.10 subnet, and I've only got 16 addresses, so it cannot reply to my other right hand router. So let's change that address to 224. do a show IP route. That looks better. Let's see if I can ping now. And there we are able to ping. So that's a couple of ways that you can use the different subnet masks to do some troubleshooting. What I'll do now is swap over to Excel and do a couple of examples to show you how you can use this method to answer the questions that you've been getting in the assignments. Use Excel just as a way of recording what we're going to do here with this lab. So I've taken here an example. It's similar to the Net Academy exercise, but just using different numbers and slightly different wording. So let's talk through it. My challenge here is that I've been given a /24 network, the 192.168.1.0 network, and the request is to subnet that network number so that I can give a subnet to 5 networks. Each has up to 20 endpoints. So how do I start this problem? Well, the first thing I've got to decide is how big of a subnet mask do I need? So I have to support 20 endpoints. Let's have a look at this table in front of us. This table equates the slash notation, what net mask ending number it refers to, how many numbers in that subnet, and how many usable hosts I have. So starting at /32, that is an ending of 255 in the net mask value. Only one possible number in that subnet. And in terms of usable hosts, we wouldn't want to use this to apply to a network. It's only used for loopback addresses, typically inside a router. The /31, that equates to a net mask ending in 254. That gives us 2 possible numbers in the subset. Remember the way I'm getting this number here in the column? This is basically, I'm subtracting the net mask from 256 to get this number here in the numbers in subnet column. So 254 from 256, I've got 2 subnet. In practice, this gives us 2 usable hosts, but this is in Cisco Networking Academy terms apparently a relatively new phenomena, and they still keep us to using the /30. So for our purposes right now, we'll just ignore /31. For /30, we have the net mask ending in 252, subtract 252 from 256, that gives us 4 usable addresses. The first is the network number, the last is the broadcast address, so I've got 2 usable hosts. /29, that gives us a net mask ending in 248, so subtract 248 from 256, 8 numbers in the subnet, subtract the network number and the broadcast address, 6 usable hosts. And we'll just do one more. /28, that gives us a net mask ending in 240. 16 numbers in the subnet as we subtract 240 from 256. And subtracting the network number and the broadcast address, you get 14. So that's pretty straightforward. What can we do with that now? Well, once we've got this table, we realize we know from the question we need to support 20 endpoints. So this is telling us that /30 is no good, /20 is no good, /28 is no good, /27 ending in the 224 mask is what we need to use. That gives us 32 numbers and 30 usable hosts. Pretty straightforward. So let's go and fill that out a little bit. With 32 numbers in the subnet, that tells me that I logically get a new subnetwork number after every 32 hosts. So my first subnet will be .0, my next subnet number will start at .32, my next subnet number will start at 64, and so on, all the way to .224. There are no more after .224 because by the time we've exhausted the 32 host, adding at subnetwork number .224, we're all the way up to 256. So let's just fill out this table. It should be pretty straightforward, right? Usable address 192.168.1.1 because we know the .0 is the subnetwork number and we can't use that. We can fill in the broadcast address as 192.168.1.31 because the broadcast address is always the last number in the subnet. So that tells me my last usable address is 192.168.1.30. Pretty cool. Okay, that's straightforward. Let's do another couple. For the second subnet, my first usable address is 192.168.1. What do we go for? It can't be 32 because that's the subnetwork number, so it has to be 33. Okay, let's follow the same practice. I'll put in the broadcast address .168.1.63. That's the very last number in that subnet, and that's the broadcast. So that tells me my last usable address is 192.168.1.62. Okay, so it should be pretty easy to follow that same pattern and complete all of the numbers here in terms of first usable, last usable, and broadcast address. The way we would then use that is to say, okay, for one location that has got 20 hosts, I'll allocate it this subnet and address all of the hosts within the first usable to last usable range. The next one I'll go to an address within the second subnet. I'll address all of the hosts in that subnet within this first and last usable address range using the correct mask .224 when I do the IP address configuration on the interfaces. And that's pretty much it. The only way to really get comfortable with all of these things is just practice. So what I would suggest is you can follow this example, you can do the Net Academy. There is the link to the subnet calculator that you have in Blackboard. Just do practice, and once the penny drops here, we can get onto much more fun and interesting things to do with Cisco routers.